lesson 5, it's going to really tie in all of the theorems we've worked on, dividing, factoring, knowing the different parts, especially your degree. Okay. Today what we're going to work on doing is focusing on the solutions, more specifically finding all solutions. Alright, now when I say finding them all, it's, both the imaginary and complex, along with the rational as well as irrational roots. This is going to be the kinds of questions that are going to be free response in your final exam. Alright, so pay attention in this video. It really ties everything together. I didn't learn this when I was in high school, and since I started teaching Math 3, factoring has become easier, knowing solutions, being able to write equations, all of that stuff has become easier and now makes more sense. Okay, so what we're going to do is start on page 20, and we're going to do some quick review. Okay, by knowing the degree of a polynomial, you know the number of roots or solution a polynomial has is equal to the degree. Okay, you can also graph the given polynomial to quickly or easily find the rational or irrational roots, zeros, solutions. Alright, once you do all of that, you're going to be left with a quadratic 9 times out of 10. And you'll have to find the remaining complex or irrational zeros. This is going to be for like your short answer stuff, and they're going to wind up telling you to round to like 1 or 2 decimal places. You're gonna get the problem wrong because you round wrong. Okay, I don't agree with it, but it's just gonna be the way it is. And as well, the complex stuff, I think it'll be like a drag and drop. So these are going to be your interactive style questions. Alright, revisiting, going back to Math 2, we're going to do this by using the quadratic formula. If it's a multiple choice, calculator. Okay, Desmos cannot do these questions all the way through, especially if they have complex solutions. Desmos won't graph them, okay, because complex and imaginary are the same thing. Alright, so quadratic formula: negative b plus or minus square root b squared minus 4ac, all of this divided by 2a. Okay, so again, once you get down to a quadratic, you can then use quadratic formula to get the rest of your answers, or get the rest of your solutions. Now, in this example, find all roots given the following polynomial. I'm going to do this example as well, write a flow map at the same time. So, first thing I always want to do, and now this just doesn't have to be with polynomials, it can be an equation. So I'm going to treat this as if it's an equation, and then that way, worst case scenario, you know how to do it. If you're given an expression, again, expressions aren't equal to anything, you can just go ahead and you'll move to step 2. But again, assuming you're given an equation, make sure it's set equal to 0. Okay, if it's not, then you'll have to do some stuff with it. but here we don't have to. Step 2, I'm just going to graph the given expression. Alright, so when I graph it, I have y equals x to the 4th minus 81. Okay. Well, I then very simply can click on my real solutions, again, where the graph crosses the x-axis. So I know I have solutions at 3 and -3. After you graph your expression and write down, I'm going to say, your rational solutions, you need to then turn these into factors. Again, the way you turn the way you turn solutions into factors is just rewrite them and take the opposite sign. Okay. So you're going to turn step 2 into factors, and then you're going to multiply them. Alright. So when I multiply these, I can have x squared plus 3x minus 3x minus 9. Again, way I do this is box method. X minus 3, x plus 3, x squared minus 3x plus 3x minus 9. Again, simplify, so I'm left with x squared minus 9. Okay. From here, what I'm going to do is divide original by whatever I have from step 4. Okay, so if I have x to the 4th minus 81, all of that divided by x squared minus 9. And most of y'all would want to use synthetic division right here. You can't now because I don't have a linear term on bottom, I have a quadratic. You could have used synthetic division, but you would have had to have started here, divided, here, divided. What I'm going to do is I'm going to use long division because it's going to immediately take me to my quadratic at the end. Alright, so again, x squared minus 9, x to the 4th plus 0x cubed plus 0x squared plus 0x minus 81. Again, what times x squared is equal to x to the 4th? It's just x squared. You then distribute this x squared over here. X squared minus 9x squared. Subtract x to the 4th minus x to the 4th. They cancel. I'm left with 9x squared minus 81. So what times x squared equals 9x squared? So x squared times what equals 9x squared? It should be 9. So multiply these, 9x squared minus 81 cancels, subtraction change to addition, swap signs, and I'm left with 0. So my resulting is x squared plus 9. And before I go any further than this, I want to verify that this is right. The way I do that is, again, I'm going to type x squared minus 9 in, and I'm going to also do x squared plus 9. Reason I do this is because if my graphs overlap, then mathematically I was right when I divided. I don't want to get to the end of the problem and realize that I messed up somewhere, okay? So after I've done this, this is what's left over, and this is my quadratic. Once you do all of that, I would say step 6 would be check division by Desmos. Step 7 is going to be use quadratic formula. Again, quadratic formula, negative b plus minus square root b squared minus 4ac, all of that over 2a, where a is your coefficient of the x squared term, which is 1. B is your coefficient of your x term, or your linear term. Right now it's not 1, so it's a 0. C term is your constant. Then you just plug this stuff in. Okay? So, negative 0 plus or minus square root 0 squared minus 4, a is 1, c is 9, all over 2, a was 1. If you're going to make a mistake once you get done dividing, this is going to be it. Take your time, slow down, make sure you don't have any sign errors. Negative 0 is just 0. So I'm going to have plus or minus square root. 0 squared is 0. Minus, and then 4 times 1 times 9 is 36. All of that divided by 2, which simplifies to plus or minus square root negative 36 divided by 2. And this is why you have to have a calculator. Eventually we have to think back to math 2. When you have negatives inside the square root, it's really i's. But so plus minus square root of 36 is 6, but when you have a negative, it's going to be an I. Divide that by 2, and now you can do numbers divided by numbers, plus or minus 3i. 8, again, I'm going to verify by calculator. Okay, so if I have to verify this by using a calculator, what I'm going to do is go to mode, and I'm going to change it to a plus bi, which is going to let me use i's. I hit enter, and I can clear out. Up here at the top, if you can see it, it'll actually tell you a plus bi mode. From here, what I do is I take a solution. So I'm going to type 3. Where you get the I at on your calculator is second decimal. Store that value for x, and then you want your calculator to remember it, so you hit enter. And now you type your original, x to the 4th minus 81. When I hit enter, I want to have it be a root or a solution. Again, root or solution has a value of 0 when you evaluate the function. I hit enter, I get 0, so 3i is good. Negative 3, second decimal, I, store x, enter, and then again, I check and I verify 0, 0. Okay? And I can also do the same thing with my real solutions, or my rational, my pretty ones. See, when I plug 3 in, evaluate it, give me 0, negative 3, store x, enter. Evaluate it again, I also get 0. Okay? So it's a lot of work.